Hey everyone, Mr. Houck here. In today's video, we're going to be looking at the key to the parabolas practice quiz. So starting here with number 1, we want to find the equation of a parabola with the following information. We're going to be given the vertex is -1, -3, and the focus is -17/16, -3. So the strategy here, we know that when we are trying to find the equation of a parabola, we need three things. We need the direction of opening, we need the vertex, and we need that p-value, p being that distance between the vertex and the focus, or between the vertex and the directrix. So you can look at p either way. So we start here with a quick sketch. We can see that our vertex here is in the third quadrant, so we're just kind of sketching that third quadrant here. We have the vertex at -1, -3. We have our focus point slightly to the left of it. -17/16 is slightly to the left of -1. So there's estimated where our focus is. And because of that, we know a couple things here. Since the focus is always kind of bound inside these curves, we know that our parabola is going to be opening left. We know that the vertex is -1, -3. And if we can find that distance between the focus and the vertex, that's going to give us a p-value. Well, it's pretty easy to find that distance here because notice they have the same y value, so we're really just looking at the x distance, the distance between the x values. Well, from -1 to -17/16, that distance between the two is 1/16. And one thing you can do, you can either change this to a decimal and convert that. And so for example, if I did -17/16 here, -17/16, we get -1.0625. So -1.0, this right here, -1.0625. Between -1 and -1.0625, we can see that that distance is 0.0625. And 0.0625 as a fraction is 1/16. So that's one way that we can see us getting the 1/16. Or we can just change the -1 to be -16/16. And now it's really easy to see that the distance between these two is just 1/16. And notice that because we are opening left, and left is a negative direction in the x direction, our p-value has to be negative. And once we have that information, we go through and we start to plug in the pieces to the skeleton of the equation. Opening left means we have a horizontal parabola. Horizontal means we're starting with x. So we know which equation to use. The x-coordinate of the vertex is -1, so we can see that it's eventually going to turn into +1. We know the signs will change. Our y-coordinate of the vertex is -3. That'll end up giving us a +3 in our equation. And we know that this p-value of -1/16 gets put in right here, 1/4p, so 1/4 times -1/16. Throw that in the calculator if you need to, but you end up getting -4 overall. So that gives us answer choice A. For number 2, find the equation of the parabola with the following information, vertex and directrix. So same deal, let's start with a nice little picture. We have our vertex as the point -8, 5. That's estimated to be over here in the second quadrant. The directrix, if you take that 19/4 and turn it into a decimal, we get 4.75. So notice that, this directrix is a horizontal line. Y equals some number will always give us a horizontal line. So we have a horizontal line at 4.75, and that y value of 4.75 is just slightly below our vertex y value at 5. So what that's doing is this directrix being right here slightly underneath the vertex is forcing the parabola to open up. So we know our parabola opens up. We know the vertex is -8.5 because we were given that bit of information. And the p-value is going to be that distance right here between the vertex and the directrix. That's going to be our p-value. Well, that's between 4.75 and 5. That little distance is 0.25. And since we are opening up, the p-value has to be positive. So now we take that information and we just start to fill it in again to the skeleton. Opens up as a vertical parabola, meaning we're starting with y. The x value of the vertex is -8. We know that's eventually going to turn into +8. We know the y value of the vertex is -5, or +5 here. That'll eventually turn into -5 in the equation. And the 1/4 gets put into the p-value in the 1/4p. Right there. So 4 times a fourth is 1. 1 divided by 1 is 1. So we get that 1 right there. And that gives us answer choice B. Number 3, identify the focus of the parabola below. Notice that our parabola that we're trying to identify the focus of is in general form. We don't want to have it in general form to identify the focus. We need it in what we call transformational form. So in order to do that, we need to be able to complete the square. And to complete the square, we need to move any of the variables that are the squared variables, or any variable that is related to the squared variable. So here we have y that's being squared. So anything with a y with it, these two right here, need to get moved to the right side. So we're going to subtract the 2y squared, we're going to subtract the 20y, and anything that didn't have a y with it, we're going to leave on the left. So x plus 51 stays there on the left. Now looking at this, we're going to complete the square on the right side, factor out the -2 for starters. When you factor out that -2, you end up with y squared plus 10y. And just remember that factoring is like division. So if I'm factoring -2, I'm taking those terms and I'm dividing them by -2. So here we get y squared, here we get positive 10y. Then we do our little completing the square game. We need to figure out what number right here will complete the square. Well, half of 10 is 5. 5 times 5 is 25. That's where that 25 comes from. And we don't want to forget to balance this by taking whatever that 25 is, or whatever that number is right here, and multiplying it by the number that we factored out. So -2 times 25, that's what we have to balance the equation with on the left side, which is going to give us a -50. Combining like terms on the left side, we get x plus 1. On the right side, we completed the square. We have -2 times y plus 5 squared. And now we are in a form that's going to be a lot easier to find our focus from. So in this form, we know to find the focus, we take whatever number is out here in front of the parentheses, which is -2 in this case, and we're going to set it equal to 1 over 4p. Take that -2, it's nice to represent it as a fraction, -2 over 1, so that you can then cross multiply. So -2 times 4p is -8p, 1 times 1 is of course 1, divide the -8, and you get p equals -1/8. Once you know that value of p, we have to figure out where we're going to add that value of p in. Well, for the focus point, what we need to do is we need to figure out, what direction is this parabola opening in, and then the direction that the parabola is opening in is going to determine which value of the vertex we add the p to. Well, since this is an x right here in our form, we know that our parabola is going to be a horizontal parabola. So we want to be adding the value of p to the coordinate of the vertex that determines the horizontal direction, which is the x-coordinate of the vertex. So we take the -1/8, we're going to add that p-value of -1/8 to the x-coordinate of the vertex. Our x-coordinate of the vertex was -1, so we have -1 plus -1/8, which will give us -9/8, and the y-coordinate of the vertex remains unchanged, which is going to give us answer choice C. All right, number 4, what is the directrix of x equals -1/4 y plus 2 squared? So very similar to number 3, in order for us to find the directrix or the focus, we need to find the value of p. Now, fortunately for us, this is already in the form that we want it in, so we can go ahead and take that number on the outside of the fraction, or outside of the parentheses rather, which is -1/4, and we set it equal to 1 over 4p. Cross multiply, so -1 times 4p is -4p, 1 times 4 is 4, divide the -4, and we get that p equals -1. Then to find the directrix, well, because this is a horizontal parabola, we have that x right there. If you go to the first day of notes where we put all the formulas and stuff with the characteristics, you can see that the directrix for a horizontal parabola is h minus p. H is the x-coordinate of the vertex. P we just found to be -1. Well, if we look right here, there's nothing being added or subtracted to the p, or to the x rather, so that means the x-coordinate of the vertex is 0. So 0 minus -1, double negative there, we get x equals 1 as the equation of the directrix. So our directrix is a vertical line, x equals 1. All right, number 5. What is the focus of the equation x minus 3 equals -3 y plus 5 squared? So again, we're in the form that we want. Anytime we're looking for a focus or a directrix, we need the value of p. So we take that number on the outside, -3, represent it as a fraction, set it equal to 1 over 4p, and cross multiply. -3 times 4p is -12p, 1 times 1, positive 1, divide the -12, we get p equals negative 1/12. Now we need to figure out, okay, we're going to have our vertex. Do we add this p to the x value or the y value of the vertex? Well, here, again, we have a horizontal parabola. We have this x leading our equation. So because we have a horizontal parabola, we need to add the p to the x-coordinate of the vertex. So we take our x-coordinate of the vertex, which in this case is 3. We're going to add negative 1/12, which you can see doing that right there. And by either doing it by hand, as we can see here on the key, you'll get to 35/12 comma negative 5. Or if you really, really needed to, you could do this in the Desmos calculator, and the Desmos calculator can simplify the fraction for you. For example, 3 plus negative 1/12. And you can see on the left side over there, it looks like you have a little fraction symbol. If you click on that little fraction symbol, it's going to convert the decimal to a fraction for you as 35/12, which will give us answer choice A. All right, halfway through now. Looking at number 6, find the equation of the parabola given just the picture. So we're just given the graph of the parabola. So as always, if we need to write the equation, if we need to find an equation for a conic, we're going to, or for a parabola rather specifically, we need the direction of opening, the vertex, the value of p. Well, the direction of opening is pretty obvious. We can see that this thing is opening down. The vertex is also pretty obvious. We can see the vertex is 1, negative 2, because we always know for a parabola, vertex is either the topmost point, bottommost point, leftmost point, or rightmost point, depending on how it's opening. So we can see our vertex is 1, negative 2. But what we can't see, what is not obvious to us, is what the value of p is going to be. So what we're going to do is we're going to start building the equation regardless. Even though we don't know what p is going to be, we start building the equation. So it opens down. That means we have a vertical parabola. That means we lead with y. We know that the y-coordinate for the vertex is negative 2, so we'll have a y plus 2. We know the x-coordinate of the vertex is a positive 1, so we'll have an x minus 1. But we don't know what that p-value is. Now, one way that we can find that p-value is by taking points from the graph and inserting them into the equation for x and y so that p is the only thing left over to solve. So the way that you do that is you find points on the graph that are easy to plot, easy to use. We don't want decimals, we don't want approximations, we want whole number values that we can guarantee are on the graph. So we have 7, negative 5 over here. This is a point that is easy to see on this graph. This is a great candidate for x and y. But real quick, I want to talk about making sure that you don't use the vertex. Because if you use the vertex, watch what it does to the equation. If I use 1 to be my x and negative 2 to be my y, well, over here on the left side, you would get 0. Over here on the right side, this would give you 0 squared. And 0 squared is 0. And 0 times this thing is going to be one big 0. You would get 0 equals 0, and you'd gain no information because everything zeroes out. So if you use the vertex, you're just going to get 0 equals 0, and everything's going to zero out. You gain no information, and you still won't know what p is. So you need to use some non-vertex point, such as this point, 7, negative 5, to figure out what p is going to be. So we're going to plug in 7 for x, which you can see happen right here in the key. We're going to plug in negative 5 for y, which you can see happen right there in the key. And then now you solve the equation to find p. Negative 5 plus 2 ends up giving you negative 3. 7 minus 1 is 6. 6 squared is 36. And we do our usual shenanigans to find out the value of p. Once we get that p equals negative 3, then we take that skeleton that we started building for the equation and we replace the p with negative 3, which is what happens right here. And simplifying, we get our answer, y plus 2 equals negative 1/12 x minus 1 squared. All right, moving on to number 7. Find the equation of the parabola with the following characteristics. Your focus is 3, negative 5. Your directrix is y equals 3. So we've done a few examples in class of this now. This is a pretty important type of example to look at. Let me get some more space here. So let's build, a sketch first. Here's our focus point, 3, negative 5. That's going to be this green point right here. I'm going to go ahead and just write in 3, negative 5, just so we have it for reference. Our directrix is the horizontal line, y equals 3, right up here. There's our directrix. And we know that directly halfway between the focus point and the directrix is going to be our vertex. So if we're looking at this here, y equals 3, we're going to be comparing y equals 3, which is a y value, to the y value of the focus, and we want to find the midpoint between the two of them, between 3 and -5. Well, to find the midpoint between 3 and -5, just do the midpoint formula. Add them together, divide by 2. That tells us that the midpoint, the y value in between this -5 and this y equals 3, that y value in between is going to be a -1. So I know that the y value of the vertex is -1. I also know that the vertex and the focus share the same x value. So because the focus had an x value of 3, in this example, my vertex has to have an x value of 3 as well. So I know the vertex is 3, -1. I also know that because the directrix is up here and the vertex and the focus are down here, that my parabola has to open down. Okay, so we know the parabola opens down. We know that the vertex is 3, -1. The only thing we still have to figure out is the value of p. Well, as you can see from the key here, the distance from the focus to the vertex is that value of p. So from -5 to -1, that vertical distance here, that's a distance of 4. And since the parabola is opening down, we have to make sure that our p is negative. And once we know that, we build the equation just like all the other examples. Opening down means we have a vertical parabola. We start with y. The vertex has a -1 for the y-coordinate. That'll eventually turn into a +1. +3 for the vertex for the x-coordinate. That means we'll eventually have a -3. And because the p is -4, 1 over 4p gives us -1/16. All right, number 8, another type of those examples. We're going to be given the focus and the directrix here. Again, let's go ahead and sketch us a graph. The directrix this time is a vertical line, x equals -13/8. That's a vertical line through -13/8. And our focus point, 7/8, 4, we can estimate over here somewhere in the first quadrant. So again, if we look halfway between -13/8 and 7/8, 4, we're going to find where the vertex is going to be, which will be right here, this little blue point right here. Well, this directrix is at the x value of -13/8. It's a vertical line going through the x value of -13/8. So I'm going to look at -13/8, and I'm going to look at the x value for the focus, 7/8, and I want that value directly in the middle. So again, we can do the midpoint formula, which will give us a midpoint or an x value of -3/8. So our vertex has an x value of -3/8, and notice that this time the vertex and the focus share the same y value. So we can go ahead and steal the y value from the focus for the vertex, which would be +4. We can also go ahead and find the direction of opening. We know that since our vertex and our focus point are to the right of the directrix, that's going to force the parabola to open right. And we can also find the p-value as the distance either between the directrix and the vertex or the vertex and the focus. But our vertex here had an x value of -3/8. Our directrix is at the x value -13/8. That distance between the two of them, -13/8 and -3/8, is a distance of 10/8, which is 5/4 when you simplify it. And because we're opening to the right, that is a positive direction, so we have a positive p-value. Throw all that into our equation skeleton. Opening right is horizontal. Horizontal means start with x. -3/8 for the x value, it eventually turns to +3/8. +4 for the y value, eventually turns into -4 in the equation. And then the 5/4 for the p-value. Put that down here, multiply it to the 4, and we get 1/5. All right, almost done. Number 9, what is the axis of symmetry of the parabola? So one thing to remember about your axis of symmetry is that it's a line that cuts your parabola in half. This particular parabola is a horizontal parabola. We know that because we're starting with x here. And we have a vertex at +3, +2. So if we start to do a little sketch here, +3, +2, we know we are opening, we know it's horizontal, and we also know that it opens specifically to the left because our p-value is going to come from a negative number. So I'm imagining our parabola opening left here with this vertex of 3, 2. Well, the axis of symmetry is going to have to cut it in half. And to cut this in half, to cut a horizontal parabola in half, we would need a horizontal line. So we know it's going to be y equals some number, and it's got to pass through the y coordinate of the vertex, so y equals 2. Then finally, in our last example, which parabola has the characteristics, has an axis of symmetry of y equals -4 and a directrix of x equals 7? Well, let's go ahead and first off, let's eliminate a couple wrong answer choices here. The axis of symmetry, if the axis of symmetry is y equals -4, then what that's telling us is that we need a horizontal line to cut this parabola in half. If the axis of symmetry is horizontal, then the parabola itself has to be horizontal. So we can eliminate C and D because these are both vertical parabolas. We need a horizontal parabola for the axis of symmetry to be a horizontal line. Now what we need to figure out is which of the two horizontal lines here, or the horizontal parabolas, is going to give us the correct directrix of x equals 7. And we can do that by finding the p-value for each one. Now I'm going to start with the p-value of the correct answer choice. So we have this -1/8. If I take that -1/8 and set it equal to 1/4p, cross multiply, -4p equals 8, divide -4, p equals 8/4, which equals -2. So if I have a p-value of -2, then I can go in and figure out, okay, well, which of these two is going to end up being correct? Okay, p-value of -2, which one's going to be correct? Which one's going to give us the directrix of x equals 7? So looking at what we know to be the correct answer choice here, this one is going to have a vertex of +5, -4. So vertex 5, -4. Here we can see that our p-value is -2. And if we just follow the equation that's on the equation for the directrix, we know that we're going to be taking, because it's a horizontal parabola, we know we have to take that p-value of -2 and we're going to subtract it from the x value from the vertex. Again, we're subtracting it from the x value of the vertex because it's a horizontal parabola. So if I do 5 minus -2, then that's going to give us 7. And we know that's going to be x equals, we know our directrix is going to be a horizontal, or not horizontal, a vertical line, because the directrix, which in this little hypothetical sketch, the directrix and the axis of symmetry should be two opposing types of lines. If the axis of symmetry is a horizontal line, then the directrix is a vertical line. So we get x equals 7. So this one gives us the correct directrix of x equals 7. This one, if you test it, would not give you the correct directrix of x equals 7.